Hello, guys. We're here once again to Valetto's Maths Academy, and today we'll be looking at trigonometry. By the end of this class, we hope to be able to understand what sine, cosine, and tangent mean, then solve problems involving right angle triangles, then apply trigonometric ratios. All right, we'll also participate in interactive tasks. Okay. Um, I believe you must have heard of the term so car toi. Okay. When we talk of trigonometry is a branch of mathematics that deals with the relationship between the sides of a triangle with its angles. It's a branch of geometry. Geometry deals with shapes and measurements and their angles. But trigonometry, trigonometry, that is triangle and metrics, which is measurements. So that's how we got trigonometry. All right. So it's not like it's a big word or a difficult thing to do. It only means how you measure triangles. And for trigonometry, it deals with mostly with right triangles. A right triangle is a triangle that has a right angle of 90 degrees. Okay. We're going to take this class slowly, as trigonometry sometimes can be a bit confusing if it is rushed. So feel free to pause the video at any time to understand and to go back to whatever you do not understand. So for trigonometry, there are some very important things that we need to understand. For instance, previously in our elementary classes, we would have gone through triangles, and we are supposed to know that the sum of a triangle, the sum of the angles, sum of angles of a triangle, I'll use this to represent angles, sum of angles of a triangle is equals to 180 degrees. Okay, we ought to have known this in our elementary class. Then there's also what is called the Pythagoras theorem. Pythagorean. I don't know if the spelling is very correct, but I think it should be Pythagorean theorem. Yeah, which states that this applies to right angle triangles, and this states that in a triangle a square, in a right angle triangle, a square plus b square is equals to c square. We'll come to this in a short while. So remember what we started with, so quatre. Okay, so we did all this in mind. We dive into the course. All right, when we talk of trigonometry, we talk of right angle triangles and their measurement. And in trigonometry, we have 6 functions. So let's say we have a triangle. Okay, I just opened a blank screen to get more workspace. So let's say we have a triangle, a right angle triangle like this, and this is our right angle, and this angle is A will represent the angles with capital letter and the sides with small letter. So we say we have a triangle like this, A, B, and C. Okay, and then the side opposite the angle is represented with a small letter. So if this is angle A, the side opposite angle A, we call it A. The side opposite angle B, we call it B. And the side opposite angle C, we call it C. Okay, so if this is our angle in question, for instance, A, the longest side of the triangle is called the hypotenuse. Hypotenuse, okay? And the side opposite the angle is called the opposite side. And then the side beside the angle is called the adjacent side. All right. So, okay, let's make this bigger. Let's make our triangle bigger so that you get a better picture of what we are doing. Okay, this is the right angle, and the right angle is always 90 degrees, remember. Then we call this angle A, we call this angle B, and we call this angle C. Okay, we denote the angles with capital letter, and we'll denote the sides with small letters. So the side, like I said before, opposite the angle is a small letter. Let us call it A. The side opposite the B, B. And the side opposite the C, we call it C. So we said the longest side of the triangle is called the hypotenuse. Then the side opposite the angle in question is called the opposite side. And the side beside the angle in question, or the last side, is called the adjacent side. All right. So, having this in mind, if we know two sides of the triangle, we can calculate what the third side would be using the Pythagorean theorem, which says that a squared plus b squared is equals to what? C squared. So that's talking about the sides here. So if we have this triangle and this side is we say this side is 6, this side is 8. We can calculate what the third side is. Okay, if we have a equals to 6, that is 6 squared plus 8 squared is equals to c squared. So 6 times 6 will be what? 36 plus 8 times 8 squared will be 64. Is equals to c squared. Okay, then 64 plus 36, this should be 100, is equals to c squared. Now to get what c is, you have to take the square root of both sides. So if you take the square root of both sides now, you're going to have square root of 100 is 10. So c is equals to 10. So here automatically becomes 10. All right. Okay. So we come to, so this is for Pythagorean's theorem. So to find the missing side, if you already know two sides of the triangle. Now we come to the trigonometric functions, or what some people like to call trigonometric ratios. Yeah, the same thing. Which says that sine A is equal to, remember what we talked about, so ka twa. Okay, this is T, so ka twa, which means sine is equal to opposite over hypotenuse, the opposite side over the hypotenuse side. Cosine is equal to, or cosine theta, if we call here theta or whatever it is equal to the adjacent side over the hypotenuse. And tan is equal to the opposite side over the adjacent side. So we'll bring that out. So sine A will be equal to what? If this is A, sine A will be equal to the opposite side, which is A, all over what? The hypotenuse, which is C, A over C. So this is same thing as opposite over hypotenuse. This is for sine A, and this is the first trigonometric function, number 1. Number 2, we have cos A will be equal to what? Cosine is adjacent side over hypotenuse. And what is the adjacent side here? Here, B will be equal to B over what? Over hypotenuse, C. So this is adjacent over hypotenuse. Okay. Number 3, the third function, SOHCAHTOA. Tan A will be equal to the opposite side over the adjacent side, which is the same thing as A over B. And this is equal to what? Opposite side over adjacent side. Okay. Then the fourth function is called the cosecant, represented by CSC, the cosecant. Okay, this is the inverse of the sine. So you can say the cosecant CSC is the same thing as 1 all over sine A. And if sine A is equals to opposite over hypotenuse, it then means that if you cross multiply, if this is equals to 1 over sine A and sine A is equals to opposite over hypotenuse, it then means that cosecant is equals to the inverse or the reciprocal of sine A, which will now be hypotenuse over opposite. To cut the long story short, you just flip this. Is the inverse of sine A. Cosecant is the inverse of sine. So just flip the sine formula to get your cosecant. So what we're saying is that if sine A is equal to opposite over hypotenuse, it then means that cosecant A will be equal to hypotenuse over opposite, which is the same thing as C over A here. And C here is 10, which is as 10 over what? Over A, opposite is 6, 10 over 6. Okay, that's for cosecant. Then the fifth function is called the secant, which is the inverse of cos. So the secant is written as secant A will now be equal to, is the inverse of cos. So you just take the reciprocal, which will be cos A is equal to adjacent over hypotenuse. So cosecant, this secant A will now be equal to hypotenuse over adjacent, the adjacent side, which is the same thing as the hypotenuse here is C over the adjacent side is what? B. The cos here is B over C, and the secant will be C over B, which is the reciprocal or the inverse. Okay, then the sixth function is the cotan. So cotan A will become the reciprocal of tan A, which will now be adjacent over opposite, and this is the same thing as B over A. Okay, so these are the very important things you must start with when dealing with trigonometric functions or trigonometry. You must be conversant with your SOHCAHTOA, which are the trigonometric functions, the 6 of them. You must also be conversant with your Pythagorean theorem and how to apply the sides. Okay, so we continue. Now, if we have a triangle, saying if we have a triangle, a right triangle, five, 3. If we have a right triangle, we have two sides, 5 and 3, and we are told to find all sides of the triangle and the 6 trigonometric functions. This is how we're going to do it. First of all, we say that SOHCAHTOA, okay. So the first thing we do is to find the last side of the, and we have an angle here, theta. The first thing we do is to find the missing side in the triangle using the Pythagorean theorem, which says a squared plus b squared is equals to c squared. So if we're to label the sides, this is our hypotenuse, and this is the side opposite the angle is the opposite side, and the last side is the adjacent side. Okay, so we have a squared plus b squared is equals to c squared, where c is the hypotenuse here. So it then means and if we call this x, it then means 3 squared plus x squared is equals to what? 5 squared. Okay, so that x squared is equal to 5 squared minus 3 squared, and 5 squared is 25 minus 3 squared is 9. X squared, 25 minus 9 is 16, so that x squared is equals to 16. And to get x, we find the square root of both sides, so that x is equals to 4. Okay, so we'll come here, it means that the missing side is 4. Now, having solved the first part of the problem, we now try to get the 6 trigonometric functions using that. All right, So the first one is using our SOHCAHTOA. The first one is sine theta, and we say sine theta is equal to opposite over the adjacent side. Then cos theta is the same thing as the adjacent side over the hypotenuse. Tan theta is equals to the opposite side over the adjacent side. Then cosecant theta, we know is the inverse of sine, so we just flip it. That will be the adjacent over the opposite side. Then the secant theta will be the inverse of the cos, which is just we flip it again, the hypotenuse side over the adjacent side. And the cotan theta will be the same thing as the inverse of tan theta, which will now be the adjacent over the opposite side. All right, so from our triangle here, the adjacent side from theta here is 3 over the hypotenuse is 5, 3 over 5. Okay, that's the value of cos theta. The value of sine theta will then be equal to the opposite side over the adjacent side, and the opposite side here is 5 and the adjacent side is 3, and this is the value of sine theta. This is the value of cos theta. Then for tan theta, this will be opposite over adjacent side, and the opposite side here is 4 over the adjacent side 3, and this is the value of tan theta. Then the cosecant theta is the same thing as the adjacent side over the opposite, so which is the inverse of sine theta. So the adjacent side here is so we just flip this one. It will now be 3 over 5, and this secant theta will then be the inverse of cos theta, which is now 5 over 3, and cotan theta is the inverse of tan theta, which will now be 3 over 4. All right, so that's the value for the 6 trigonometric functions. Sorry, there is a mistake here. Sine theta is equals to opposite over adjacent side, and the opposite side here is 4, not 5. Sorry, this is 4 and the adjacent side is 3. That is correct. The cos theta is so cosecant theta now will now be inverse of 3 over 4. Okay, the cos theta, which is adjacent side over hypotenuse, and this is the adjacent side over the hypotenuse, 3 over 5. That is correct. Tan theta, which is the opposite over the adjacent side, is the opposite over the adjacent side, is 4 over 3. That's correct. Okay, so when you flip, this one is going to be 3 over 4. You flip the next one is going to be 5 over 3, and the last one will be 3 over 4. Okay, please. Okay, let's take another question and get this more understood. So let's say we have another triangle, another right triangle. We have 9 and 12 on two sides, we need to know what the last side is. And then we have our angle here, theta. Okay, and we're told to get the last side, to measure the last side, the missing side of the triangle, and to get all 6 functions of the trigonometric functions. So what we do, remember SOHCAHTOA, which is sine is equals to opposite over hypotenuse. The cosine is equal to the adjacent side over hypotenuse, and tan theta is the same thing as the opposite side over the adjacent side. So we start by looking for the missing side in this triangle using the Pythagorean theorem, which is a squared plus b squared is equals to c squared. Remember, c is the longest side. All right, so here we say 9 squared plus 12 squared is equals to c squared. So 9 squared should be 81 plus 12 squared should be 144 is equals to c squared. So 81 plus 144 is 225 is equals to c squared. Then to get c, we have to find the square root of both sides. And if you do that, the square root of 225 is 15. So we say c is equals to 15. All right. So we come here, we put our 15 here. So now that we have all 3 sides of the triangle, we can go on and look for the trigonometric functions. So we have the first one, sine theta is equals to opposite over hypotenuse. So we can go ahead and label these sides. This is the side opposite the right triangle is the hypotenuse, which is the longest side, and the side opposite the angle theta is called the opposite side. That is why it's called opposite the angle theta, and the last side is called the adjacent side. All right, so now we have all labels on the triangle. We can get the functions. So sine theta is opposite over hypotenuse, which is now opposite here is 9 over 15. Okay, we can reduce this to 3 over 5. Okay, and then we look for cosine theta. Cos theta is the same thing as adjacent side over hypotenuse, which is 12 over 15, and we can reduce this to 4 over 5, right? If we divide by 3, this will give us 4. Divide here by 3 to give us 5. Okay, I don't think it can be reduced any further. Then tan theta will be equal to the opposite side over the adjacent side, and this is 9 over 12, and this can be reduced to 3 over 4. All right, we proceed to cosecant theta, which is the same thing as this CSA. I use it to represent cosecant. Cosecant theta will now be the inverse of sine theta, so that will now be 5 over 3. Then secant theta will now be the inverse of cos theta, which will now be 5 over 4. And cotan theta will now be the inverse of tan theta, which will now be equal to 4/3. So we have our 6 trigonometric functions all worked out. Okay.